Let's go to page 252 and let's do number 5. Number 5, you have sine of 105 degrees and you want to use half angle, so that means you want to let x over 2 equal to 105 degrees, so x will equal to 210. And after you write down your identity, so sine of x over 2 equal to plus or minus square root of 1 minus cosine of x over 2. Okay. Then after that, what you need to do is you're going to draw a triangle and to solve the problem. Okay. And you need to go ahead and do that. So you got sine of x over 2 equal to, now the plus or minus would be depends on the original problem the quadrant is in. So sine of 105 is going to be somewhere over here, so the sign is positive. Okay, so that's how you know it's going to be positive. It's going to be 1 minus cosine of 210 degrees over 2. So sine x over 2 equal to square root of 1 minus. So now you have to draw another triangle for that. Right? So that's 180 and this is 210. So you're going to get 1, 2, square root of 3, and it's going to be negative and negative. So cosine is negative square root of 3 over 2 over 2. Then what you need to do next is go ahead and multiply everything by common denominator to get rid of the complex fraction. So multiply everything by 2. So you're going to get 2 plus square root of 3 over 4. And then you're going to simplify this. So you're going to get square root of 2 plus square root of 3 over 2. Okay, and that's it. Okay, so again, make sure you do this. Okay, set whatever when using the half angle formula, go and set it equal to the half angle. Okay, let's go to number 7. Number 7, you have tangent of 15 degrees. So again, when using the half angle formula, you let x over 2 equal to the 15 degrees, so that x will equal to the 30 degrees. Okay, then you write down your half angle identity. So tangent of x over 2 is going to be equal to, go and just use the first one, probably the easiest one, cosine x over sine x. Okay. So this one, you just go and draw your triangle based on, I see x is 30 degrees. So if you draw that, that's your 1, 2, square root of 3, that's your x. So tangent of x over 2 is equal to 1 minus cosine is square root of 3 over 2. Sine is 1 over 2. Again, complex fraction, so multiply everything by common denominator. Multiply by 2, multiply by 2, multiply by 2. So tangent of x over 2, okay, is going to be equal to, well, actually, you can go and put an x over 2 back in as a 15 degrees. Okay, so let's go and put it back, put a 15 back. So make sure you know how to interchange, right? That's why you want to set this in the beginning so you can keep everything on track. So this is going to be equal to time. So this multiply you get 2. This cancels out minus square root of 3, and this cancels out, so it'll be over 1. So that's it. So you don't have to put over 1. Okay. Okay, let's go to number 13. Okay, number 13, you want to verify the identity. So you got sine of 2x equal to tangent of x times 1 plus cosine of 2x. Okay. So first copy the problem and then you compare the two sides to see which is more complicated. So again, first thing you look is a function. This have 2x. So this have two things in a function. But these are also, so they're tied. So you go to the next one. So you can see that this is more complicated, right? So you want to simplify this side. So you got sine of 2x equal to, and change everything to sine and cosine. So it's going to be sine x cosine x over 1 plus. Now the cosine, the cosine 2x. So notice that there's only one term on this side. So you try to see if maybe you can get the one term on this side. So when you look at your double angle identity, you probably, if you want to get rid of that one, you want to use a third one. So you want to use the 2 cosine squared x minus 1. So that one will cancel out. Okay. So again, you kind of have to try. If it doesn't work, try the different one. Okay. But again, you have to look what's on this side. Notice there's no 1 plus whatever. So you want to get rid of the 1. So the one you want to use is the one with the minus 1. So you got sine 2x equal to sine x cosine x times. So this cancel out. So you're going to get 2 cosine square x. And then the cosine and this will cancel out with that. So you got sine 2x equal to 2 sine x cosine x. And you already did this before, right? This is equal to sine of 2x. So you're going backwards. So this is equal to sine of 2x. And so check. Okay, let's go to 15. Okay, number 15. Again, first copy the problem. So you got 2 sine squared x over 2. You have to be careful how you write these things over here. Is equal to sine square x over 1 plus cosine x. Okay, so you can compare the two sides to see which is more complicated. This side is more complicated because you got something inside the function. This one don't, right? So go and apply your half angle formula. So sine square is going to be equal to plus or minus square root of 1 minus cosine x over 2 square, right? So that square is a square of that. So that's that. Be careful how you write the square. Okay, make sure it's very clear. Okay, so now, so when you square, plus minus square is always positive. Okay, so when you square this side, the square will be gone. So you're going to get 1 minus cosine x over 2 equal to sine square x over 1 plus cosine x. So this cancel out. So you're going to get 1 minus cosine x over 1 equal to sine square x over 1 plus cosine x. So again, the thing to focus on is the 1. Notice you want to get from here to here. If you want to get from here to here, you need to multiply by that, right? So I'm going to multiply by 1 plus cosine x. Okay? Since I do that on the bottom, I need to do the same on the top. Okay? So again, you got to look what's on the other side. You want to get from here to here, that's what you need to multiply. Okay? So when you multiply, this becomes 1 minus cosine square x. Right? That's a conjugate. And on the bottom, you get 1 plus cosine x. And 1 minus cosine square is going to be equal to sine square. So this one has a lot of writing, okay, and that's it. Okay. So again, first, copy the problem, decide which side you want to change. So change the one with a more complicated function, and then you just substitute and you work it out. And after that, you look on what's on the other side, and the key to focus on is the one with the 1. Okay. To get from here to here, you need to see what you need to multiply, and then do that, and you get the answer. Okay, let's go to 17. Okay, you got sine theta minus cosine theta squared equal to 1 minus sine 2 theta. Okay, again, first you compare. So this is more complicated, so that's going to simplify that. So this sine 2 theta is 2 sine x cosine x. Okay? And notice there's no 1 on this side. Okay, so what you need to do is you need to change this into using the identity, Pythagorean identity. Again, whenever you're going to convert the 1, that's your sine square plus cosine square. So change the 1 into sine square theta plus cosine square theta. Okay, and then when you factor, this is your perfect square, so it's equal to that already. So again, this is your perfect square, so when you factor that, you get sine theta minus cosine theta square. So again, this factor into that. So you need to know your factoring. Okay, let's go to 19. You got cosine square w over 2 equal to 1 plus cosine w over 2. So this side is more complicated because the inside is half, right? So this half angle formula. So you want to change this side. So go and change that. So this is equal to cosine half angle is plus or minus square root of 1 plus cosine of w over 2. So that's what cosine half angle is. And there's a square, so you square that. So now you work it out. So plus or minus square is always plus, and square and the square root cancel out. So you got 1 plus cosine w over 2 equal to 1 plus cosine w over 2. And that's it. Okay, let's go to 21. Okay, 21 you have cotangent of alpha over 2 equal to 1 plus cosine alpha over sine alpha. So again, this is more complicated because you have more than one thing in a function. So you want to change this side. So to change this side, first thing you have to do is you have to do the conversion. So changing to cosine alpha over 2 divided by sine alpha over 2. Then you go ahead and do the identity. So be plus or minus square root of 1 plus cosine alpha over 2 over plus or minus square root of 1 minus cosine alpha over 2. Okay? So now the plus or minus will cancel out, and this one, what you do is a complex fraction. So you multiply everything by 2. Okay? So multiply by 2. So now you become one big square root. So you got 1 plus cosine alpha over 1 minus cosine alpha. Okay? Now I'm going to put this back now. So this is equal to 1 plus cosine alpha over sine alpha. So to get from here to here, notice this is square root, this one does not. So to get from here to here, you need to multiply by square root of 1 plus cosine alpha. And you do that on the top, you need to do the same on the bottom. Okay? So again, to get from here to here. So you always have to look at what's on the other side. So this times that will equal to that. So you got 1 plus cosine alpha. Over here on the bottom, you're going to get square root of, so when you multiply this, you're going to get 1 minus cosine square alpha. Okay? Right, this is your conjugate. Conjugate becomes difference of square. And you're going to get 1 plus cosine alpha over square root of 1 minus cosine square will give you sine square. Okay? And square root of sine square will give you sine. And that's it. Okay. Okay, let's go to 23. You have a cosine of 2t over 1 minus sine of 2t equal to 1 plus tangent of t over 1 minus tangent of t. Okay, so again, first let's go and convert into, well, first let's decide which side you need to change. So this one, you want to change this side. Okay, so let's go and use identity. So cosine of 2t is cosine squared t minus sine squared t over 1 minus 2 sine t cosine t. Okay, and next is that notice this normal square on this side. This has square. So what you need to do is this one is probably a little bit more tricky. So what you need to do is that you need to go and get rid of the square. So what you want to do, go and do the factoring. Okay, but before you do that, let's go and, so in order to factor the bottom, you need to change the 1 into cosine square minus sine square, right? Okay, so let's go and do that. So change 1 into cosine squared t plus sine squared t. Okay. Then you're going to do the factoring. So you're going to get cosine t plus sine t, cosine t minus sine t. On the bottom, this is a perfect square for subtraction. So you're going to get cosine t minus sine t, cosine t minus sine t. So you have to really know your factoring. Okay, and then this is going to cancel out. Okay, I'm going to write this over here. Okay, so things started looking good now. So to get from here to here, notice you have to divide everything by cosine t. Okay, so divide everything by cosine t. So you got cosine t over cosine t plus sine t over cosine t. And you got cosine t over cosine t minus sine t over cosine t. So divide every term by cosine t. And after that, you're going to get 1 plus tangent of t over 1 minus tangent of t. Okay, and that's it. Okay. Okay, let's go to 25. Yeah, tangent of 2x equal to 2 tangent x over 1 minus tangent square t. X. Again, this is identity you have to prove. So you cannot just go and use it. You cannot just go and say, oh, okay, you can just use that and write it down, because you cannot use the identity itself to prove itself. Okay, so that would be like circular reasoning. So you just have to apply the identity. So 2x means x plus x, right? Then you apply the definition, the identity for tangent x. So this is going to equal to tangent x plus tangent x over 1 minus tangent x tangent x. Okay, I can apply your sum identity, and then from here you're going to get 2 tangent x over 1 minus tangent square x. And check mark. Okay. Okay, let's go to 27. Yeah, tangent of x over 2 equal to sine of x over 1 plus cosine x. Okay, so this is more complicated, so you want to simplify this side. So first thing you want to do is change into sine and cosine. So this is going to be sine x over 2 over cosine x over 2. Then you're going to expand that, use a half angle, so this would be plus or minus square root of 1 minus cosine x over 2 over plus or minus square root of 1 plus cosine x over 2. Okay, so this will cancel out, and you want to multiply complex fraction, you want to multiply by 2, right? So this will cancel out. So you end up with square root of 1 minus cosine x over square root of 1 plus cosine x. Okay. Okay, so now you have to look on what's on the other side to give you a clue. So this side is this, right? So to get from here to here, you need to get rid of the square root. So you need to multiply one more of the same square root, right? Two same square root give you like an integer, right? So you need to multiply by one more of that. So that means you need to get one same thing on the top. Okay? So you can multiply. So when you multiply, you're going to get 1 plus cosine x. So that takes care of the bottom. Now on the top, when you multiply, this is conjugate. So when you multiply, you can become difference of square. Okay? As you do more of the problem, you become more experienced, so you can remember the identities, and you can have idea what to do. So 1 minus cosine square will equal to sine square. Okay, and square root of sine square will give you sine. And that's it. Okay, let's go to 29. Okay, you have secant square x equal to secant 2x times 2 minus secant square x. Okay, so this is more complicated, so you want to change this side to match that. So keep the left-hand side the same. So secant is 1 over cosine. So this is 1 over cosine of 2x. So it would be 2 minus 1 over cosine square x. Okay? Okay, so first let's go ahead and expand this. So cosine, again, you have a choice of which one to do. If you're not sure, just go ahead and use sine and cosine. So just try it out. If it doesn't work, and you just try something else. Okay. So you're gonna have a cosine square minus sine square x. And this one you make into common denominator. So when you subtract, you get cosine square x. So you're going to get 2 cosine square x minus 1. Okay. Well, actually, if you notice from here, if you notice 2 cosine square x minus 1, this is equal to cosine of 2. This would be 2 cosine of x. Okay, so actually you probably don't even want to do that. So let's go and change this back, because this is quite easy. Because this is equal to cosine of 2x. So actually this cancels out. So this one is not too bad. So 1 over cosine square is secant square. So check. Okay. So sometimes when you do that and you say, wait, we don't need that, so you can go and change it back, because this already gives you something very obvious you can cancel. Okay. Okay, let's go to 43. Okay, 43. You have sine of x equal to 7 over 25, and the angle is pi over 2 less than x less than pi. So this tells you what quadrant is in. Okay, and so you're looking for sine 2x, cosine 2x, and tangent 2x. So first you want to do is go and draw the triangle. So between pi over 2 and pi is this one over here. Okay, right? Because here's your pi over 2 and here's your pi, right? So it tells you what quadrant it's in. And sine is 7 over 25, so this will be 24. So you have to know your spatial triangle. Okay, so let's go and do sine of 2x. So sine of 2x equal to 2 sine x cosine x. So this would be 2 times sine x would be 7 over 25. Cosine x would be 24 over 25. Okay, so this will equal to 625. And again, get your calculator and multiply out. So 2 times 7 times 24 equal, so 336. Okay. Okay, then let's go and do the cosine of 2x. Cosine of 2x equal to cosine square x minus sine square x. So cosine is 24 over 25 square. Sine is 7 over 25, and you square that. Okay, so go and work it out. So 24 times 24 equal 576 minus 49. Okay, so minus 49 equal. So this will equal to 527 over 625. Okay. Okay, now tangent of 2x. Well, if you know this, right? Tangent of 2x is sine 2x over cosine 2x. So you can just use this over that. Or you can use the regular way. Okay. Now so easy if you just go and use sine 2x over cosine 2x. But the danger of that is if you make mistake on that and use the wrong answer over here, you're going to get it wrong too. Okay. So so you kind of have to decide which one you want to use. So if you want to be safe, just go and do it. Just do this. Okay. So it'd be 2 times. So tangent x is sine over cosine. So it'd be 7 over 24 over 1 minus 7 over 24. I'm going to write it out twice. The reason for that is so that when I multiply by my common denominator, remind me that I have to do it twice. So it'll be 24, 24, 24, 24, 24, 24. Okay? So now I'm ready to simplify. Again, the reason I write everything out so that I can cancel and I can see what's left over. Okay? So make sure you multiply, right? So 24 times 2 times 7 equal, so it'll be 336. And over here, 24 times 24. So it'd be 576 minus this cancel out, 49. And so tangent of 2x equal to 336 over 527. Okay? And kind of, you can use that to check. See, this over that, right? The 625 will cancel out, so you're going to get 336 over 527. Right? See that? 336 over 527, and that's what you get. Okay. Okay, let's go to 45. You got cotangent of x equal to negative 12 over 35. And again, the angle is between negative pi over 2. So this is between 0 and, so it's right over here. And cotangent is cosine over sine. So cosine is 12, sine is 35. And the negative would be this. So don't just assume that negative goes with 12. Okay, you got to look at the picture, decide the negative goes with that. Okay, and then from here, use Pythagorean Theorem. So 12 squared equal to 144. 35 squared equal to 1225, and you add. So you get 1369, and let's see if you take the square root. Oh, it does. Okay, so 37. Okay. Okay. So sine 2x is equal to 2 sine x cosine x. So it'd be 2 times sine would be, so it would be negative 35 over 37. Cosine is 12 over 37. So this will equal to, get your calculator, work it out. 2 times 35 times 12 equal, so negative 840 over 1369. Okay. And cosine of 2x would be cosine square x minus sine square x. So you're going to get 12 over 37 square minus negative 35 over 37 square. Okay, so you're going to get 144 over 1369 minus 1225 over 1369, and so you're going to get equal to negative 1081 over 1369. Okay, and tangent 2x, I'm just going to use a shortcut. I'm just going to use this over this, right? So I'm going to get 840 over 1081, and the negative will cancel out. Okay, we can do it a long way. Okay, either way. Okay, page 253, number 47. You have cosine x equal to 1 over 4. You got 0 between x and 90 degrees. So you're looking for sine of x over 2. Cosine of x over 2. Okay. So for this one, you kind of have to figure out what quadrant this is. So you have to divide this by 2. So you have to do this. Divide by 2. Okay. So you know that x over 2 is going to be in quadrant 1. Okay. So this is quadrant 1. So you know that when you're doing the plus minus, right? So you can use that to figure out that it's going to be a plus, because over here sine is plus, right? Okay. So it's going to be 1 minus, and then you have to draw one more triangle on. So cosine is 1 over 4, so it'll be 1 over 4 over 2, and multiply by common denominator, multiply by 4. So sine of x over 2 equal to positive square root of 4 minus 1 over 8. So equal to square root of 3 over 8. Okay. Now if you just leave it like that, that's fine. If you want to simplify it, that's fine. Okay. Now for cosine of x over 2 equal to plus or minus 1 plus cosine x over 2. So cosine x over 2 cosine x over 2. So again, if you look at the quadrant 1, the cosine is going to be positive. Okay, so that's how you know it's going to be positive. And it'll be 1 plus, now cosine of x, again, it tells you it's going to be 1 over 4 over 2. So it's very similar. So just multiply by common denominator. So cosine of x over 2 equal to positive square root of 4 plus 1 over 8. So cosine of x over 2 equal to square root of 5 over 8. Again, if you just do like that, that's fine. If you want to simplify, if you simplify, this would be 2 square root of 2 and multiply by square root of 2 square root of 2. Again, so you got square root of 6 over 4. Okay, this one, if you simplify, you get square root of 5 over 2 square root of 2 and multiply by square root of 2 square root of 2. So you get square root of 10 over 4. Okay.